Alright, so to lead you through some more examples, it says determine whether you should use factoring square roots or completing the square to solve the equation. So you have quite a few tricks up your sleeve, and part of being strategic is knowing which one's going to save you the most effort. So for problems like 14, I zone in right away on the fact that I see a GCF of x, which means I can factor out an x. If I do that, I'm going to have two problems that I can set equal to 0 and solve. So I feel like that's going to take less work than anything else I do. So I personally would say factoring because I can actually factor out a letter, and that'll change it now to no longer solving a quadratic equation. I'll be solving two linear equations. If I'm looking at 15, anytime I see parentheses squared, I'm going with the square root method. That's going to be the fastest way. So the worst thing you could ever do is FOIL all of that out. That'd be kind of defeating the point because you may have to put it back into that format when you do complete the square. So just leave it like that and square root both sides. 16, I would say either factoring or the square root method. You could simply add 225 to the other side and square root both sides. Or you may realize that's a difference of squares, which factors very nicely. And then for the last problem, I'm running through the factoring in my head real quick, and I'm doing 4 times 12, and I'm thinking, is there anything that makes 48 and 8? And I can't think of anything right away, so I think factoring will probably not work, and if that's the case, I have to use complete the square because it's not set up to use square roots. So we're going to put these methods to the test and see just how much time and effort they save us. So we're going to factor out the GCF of x, leaving me with x and x plus 7. So what I have now are two linear equations basically being multiplied. You can use the zero product property and solve each of them. So I get 0 and negative 7. So I feel like that was a lot less work than doing complete the square. All right, number 15, I'm going to square root both sides. I get x minus 1 equals positive negative root 35, which does not simplify. So my answer is 1 plus or minus root 35. So again, anytime I have parentheses squared, that's basically like the final step of complete the square. So they pretty much did all the work for you as if they were doing complete the square, and they just asked you to finish it, which is really nice. I think I'm going to use the square root method for this one. I'm just going to add 225 to the other side and then take the positive negative square root of both sides and get positive and negative 15. And then if I do complete the square, there's nothing wrong with using these numbers. However, it will make your life easier if you divide everything by 4 and you work with x squared plus 2x plus 3 equals 0. So I recommend doing that. And then what I need to realize is if I cut 2 in half and then square it, I don't get 3. So we need to find a different number that will complete the square. And we'll have to move 3 over and make it negative 3. So half of 2 is 1, and 1 squared is 1. So I'm going to put 1 here and here. And now I can rewrite this as x plus 1 quantity squared equals negative 2. And then, of course, square root both sides and get positive negative I root 2. So my answer is negative 1 plus or minus I root 2. And then we're going to throw a little geometry your way. Not a big deal. Area is 1/2 base times height. And they're telling you the area should come out to 30. And there's lots of ways to do this. We can distribute 1/2 to the parenthesis with x plus 2. We can do 1/2 times the 3x. You just can't distribute to both parentheses. Or we can just multiply both sides by 2 and disregard that 1/2 altogether, which is probably the way I'm going to do it. And then if I go ahead and distribute 3x, I'm going to get 3x squared plus 6x and then 60. And again, working smarter and not harder, divide everything by 3 and save yourself some work. So a lot of this is just going to be you being observant. I don't think this is going to factor, so I'm going to go ahead and set it up to complete the square. Oops, this should be equals, my mistake. So we have x squared plus 2x minus 20 equals 0. And so if I do half of 2 and square it, I'm not going to get 20, so we'll have to find out what does work to complete the square. And that would be 1 again. So now I have x plus 1, quantity squared, equals 21. We'll square both sides again. And my final answer will be -1 plus or minus root 21. All right, so then we have another problem. It's a trinomial, and it says write it in vertex form. Then identify the vertex. So there's actually a way we did this in the past. So I'll call this method 1 in its review. First, we would get h using the formula for h. Then we would get k, and then we would plug those values into the formula a times x minus h squared plus k. However, to fit in with this unit, they're also showing you an alternative way. So I'm going to show you both ways, and then I think we'll vote on which way is easier. So we can actually use the completing the square process, end up moving the 22 around, and then we can make it look like vertex form. So if I do method 1 first, you have to remember the formula for h is opposite b over 2a. In this case, b is 6 and a is 1, so those get filled in. And that gives me an h value of -3. And then in order to get k, you would plug h, your value for h, back into the original equation, which is right up here. So we'd have to do the square of -3 plus 6 times -3 plus 22, and we should get 13. So now I know h and k, and I was already told that a was 1, right? The number in front of x squared is 1. That's all I need to do vertex form. You fill in a, h, and k, so we're going to do that, and we get the following form. And of course, my vertex is going to be -3 for h and 13 for k. So that was the old way that we did it. We did that way back in like chapter 1. Method 2. We're going to start by setting the x squared plus 6x plus 22 equal to 0. And that allows me to move the 22 over, since 22 is not making this trinomial into a square right now. So then I'm going to realize I need to find a number that will make this trinomial into a square. And that number is going to be 9, using that b over 2 squared formula. So I will have to add 9 to both sides. And that gets me -13. And I can factor the right side into x plus 3, quantity squared. Move the 13 back over. So that ends up being my k value. And then we just swap 0 back out for f of x. So either way, we still get the vertex -3 and 13. So I just want to show you both ways. Your textbook thinks this is amazing, when I really think that this is far less work. So that would still be my vote if I had to put something in vertex form. But we always like to show an alternative way. Maybe some kids prefer this way more, and that's fine. But we like to show you multiple things you can do. That way, if you ever get stuck, you have a fallback. And then we have one more problem. It is about a golfer hitting a golf ball in the air. So kind of looks like something like that if you were to graph it. This is the function that matches the path of travel. So letter A, right off the bat, it says find the max. And you guys were trained that anytime you heard the word max, you thought of k. So you know right off the bat they want k, but in order to get k, you need h, which is why we did the problem previous to this. So I'm actually going to use the old way of doing that. I'm not going to do the whole complete the square thing. All right, so I'm going to do opposite of b over 2a and end up getting positive 5 over 2. I'm going to plug that back in for t in my formula, and I end up getting 100.1. So the max height of the ball is 100.1 feet. Now letter B says how long does it take to hit the ground? Ground means 0 feet high, so we put 0 in for the height. And then we're going to compute our t value for which we get 0 as the height. So it doesn't appear that it's going to factor for me. You can certainly try, but the decimal is kind of throwing it off. All right, I definitely can't use the square root method. So I'm actually going to go with complete the square. The first thing I'm going to do is divide everything by -16. All right, so that gets me t squared, -5t, and I am using a calculator to help me here, but you get 0.00625. So I recommend a calculator if they ever put a decimal in a problem. I'm going to move the 0.002625 over because that's not going to make this a square. And then I'm going to use my b over 2 squared formula, and I am going to complete this square. So if I do -5 over 2 and then square it, I get 6.25, and I have to put that on both sides. And now I can factor this side into t minus b over 2, which is 2.5 or 5/2 squared. And then if I add these together, I get 6.25625. We're going to square root both sides. And again, I'm using a calculator to aid me. So we're going to square root. Now, because it's a word problem, I want a positive answer, not a negative answer. So I'm going to go ahead and take the positive square root of both sides and get 2.5. And then I get roughly, t is going to be about 5 seconds. So that ball will be in the air for just about 5 seconds. So again, anytime you have like a physics problem and they're using a decimal in the formula, I strongly recommend that you pick up a calculator and use that to help you, or you're going to go crazy.